Would like to take this opportunity to welcome everybody to our Getting Started webinar. My name is Ed Robledo. I'm part of the EAGLE support team and community team. And together with Jorge Garcia, we've been working with EAGLE for approximately, I would dare to venture, around way over 30 years. So we have quite a bit of experience. We run the support as well as the community portions of it. So if you ever visit the forum, you'll see Jorge is active pretty there. If you submit any cases in regards of EAGLE, that's where I come into play. And I try to put together as many webinars as we can throughout the month and some content on our YouTube channel as well. Now, today we're going to be talking about EAGLE. And before we actually dive into EAGLE, I just want to do a brief intro into it. So EAGLE is basically a platform that consists of multiple editors. Those editors consist mainly of the electronic schematic editor, which is the logical representation of your circuit. Then we have the board layout, which is the actual physical aspects of the board, and they work together. They're tied to each other. And then we also have the the library editor, which gives you the capability of creating your components. On the library side, we actually are going to be hosting many webinars, yes, on the library editor, since there's so many portions to it. So we'll be hosting those. Make sure to visit the control panel homepage where our list of webinars actually show up as well. Now, the first thing when you install EAGLE and you launch it for the first time, you're going to be running into something called the EAGLE control panel. From the control panel is where you're going to actually see a broad spectrum of all the concepts of EAGLE. So you'll be able to be exposed to your libraries, to your design blocks, your design rules, and so forth. Now, from the control panel, we have something called the schematic editor. Schematic editor is where you can actually be creating the electronic logical representation of your circuit board. Here you're going to be adding components from our libraries and putting it together and making the connections at that point. From there, you're going to be creating the circuit board. And today we're only going to be working on the schematic editors. We're going to put a frame down, put some components down. So I'm going to go ahead and stop sharing my screen. That way Jorge could go ahead and take over.
All right, so we're looking here at the EAGLE control panel. We have the various trees. In another video, you can get more details on how the control panel works. For our purposes, we're really interested in the projects tree. There's obviously examples that ship with EAGLE, and you can use those to help you learn. But in our case, we want to start our own project. So I'm going to right-click on the projects folder itself. This project folder is located in Documents, EAGLE. This is where we encourage you to save all of your work. Every installation of EAGLE expects that folder to be there. So if you do save your work there, then you'll never have to worry about moving things whenever you reinstall EAGLE or you install a new version. So that's what we recommend. If you have a preferred workflow, then you can do that by going to Options Directories. So I'm going to go New Project. Getting started. Today is May the 12th or the 13th? 13th, right?
Today is the 13th, yeah, man.
2019. Okay, hit enter.
No, today's the 14th. Sorry about that.
14th? Well, it's close enough.
Sorry about that.
So we're going to right-click on the project. You see that it has the E, New, Schematic. And we have the schematic right here.
Jorge, if you don't mind, could you just go a little bit through the interface, the different menus that you're seeing there? That way we have an idea.
Let's do that. So here on the left side, you have most of the commands that you'll be using while working in EAGLE. So these icons you do want to become familiar with. The top toolbar, topmost toolbar, has most of the normal file functions, you know, open, save, print, things like that. This button, which allows us to switch directly to a board, backwards and forwards. It's going to come in handy, especially on our next webinar where we go into the board. You can open a library from here. You have the script and ULP icons, the zoom icons, and then here we have a design link which is used for interfacing with Element 14.
Jorge, could you tell them a little bit about the help there really quick, the help file, the drop-down help?
Oh, drop-down help.
Like to get to the documentation and so forth?
Yeah, we have the general. So here you can type in commands. The built-in help is most useful for finding commands and how to use them. So like if you type in route, and you hit enter, then you go to editor commands, go to route, and you'll find the page. It gives you all of its options, gives you other commands that may be associated with it. So this is for in my opinion the most important part of the help is the command references, because you can just go and you can see all the options that are associated with a given command and what it can do, how you can change different settings and things like that. So in my mind, that's the biggest help here. With that said, there's more than just that in help. You know, you have the different little command line options. Over here for keyboard and mouse, there's that. Generating
And the
output.
help file is kept pretty much up to date with every release.
Yeah.
There's a lot of time involved in updating the help with every new release, and our cadence of releases is approximately 6 to 8 weeks. So the help file, you always get the latest information.
Correct. And this part here, this is really important. The user language, this is the main reference on the UOP language. So that's the other big thing that the help has. So lots of useful information there. If you want to get to the manual, the PDF manual, you go to help documentation. And that'll take you to some other documents that are useful. So like here for layer setups, if you have like a weird layer setup you need to do, there's lots of examples in this document. You have the manuals, and then you have the UOP documentation in PDF also available here. So let's talk about a few things that are new in the latest version of Eagle, which is what you'll see here, the inspector and the selection filter. Now, selection filter can be turned off. What I typically like to do and what I find is best is I try to tab them. Whoops. Come on. There we go. So that way I can just tab between the two. I find that preserves the majority of my space, and that gives me more area to work in, and I can very easily switch between the two. So I find this feature to be the most useful. I think you can also tab the Sheets window if you want. Oh, come on. So you have to move it a little bit. There we go. So you can actually tab all three and have even more space. So it's something you want to be aware of. Now that you have these new options, you can tab them, and it makes it really easy to switch between them. And you can still preserve your drawing area. So let's go ahead and get started. I did mention this is a simulation toolbar. So all of Eagle simulation features are here. This layer is the active layer, so it gets preference in the selection. So let's go ahead and get started. We're going to go to the add command. And the first thing we want to do is we want to focus on how you can search for parts. This is a very key thing in Eagle. Eagle search is not like Google. Okay, we all love Google search. We know that if we're kind of in the ballpark of what we're looking for, then it will give us something useful. But that's not the case with the search here in Eagle. Eagle is an exact match search. So if what you type in is off by a letter or a number relative to what's in Eagle's built-in libraries, then you're not going to get a result. Okay, so to illustrate that, let's say we search for LM555. When we search for it, you'll see that you get no match. Okay, the reason for this is that there's something that I missed, some letter, some number. So the way you handle that, the way you go around this exact pattern match, or the way you can leverage it effectively, is to use wildcards. So for example, question mark, there's only two, so it's not that hard to learn. Question mark is basically a single character wildcard. So what it's basically saying is if LM555 with some character at the end, that's not a space, appears somewhere in the name of the device or in its description, then that's a valid result. Let me check it out. So I'll hit enter, and now we get what we're looking for. Okay, and we can see why it didn't show up before, because I hadn't put in a D or an N. Now we can generalize further. Let's say instead of LM, I just put an asterisk. So asterisk is a wildcard for any number of characters. So it could be 1,000,000 characters in front of the 555. If it's those 1,000,000 characters, 555, and then some character at the end, if that criteria is satisfied, let me see those results. Now when we do this, you're going to see that it widens out the net even a bit more. So now we get all the different 555 variations that we could use. Okay. Now the most flexible, and this is the one that if you can't remember the others, this is the configuration that is the most helpful and the cast the widest net. So it's basically asterisk, whatever you're searching for, asterisk. So basically, if 555 shows up anywhere, then that's gonna come back as a valid result. And the main advantage of this type of search mechanism is just that it's fast. You can have a very large library, and as you can see, I get results pretty much instantaneously. Now in this case, because it's the widest net, there's obviously lots of things here that we're not interested in, but we do find the component we want. So keep that in mind. We're working with Eagle. You have two wildcards, question mark and asterisk. If you can't remember that, the most important thing to remember is using asterisk very liberally. If you do that, you'll get the widest, the most general search, and you'll almost always find what you're looking for. If you can't find it that way, it just means it's not an Eagles library. So go ahead and bring this one in. Okay. So from this point forward, I'm just going to go through the various libraries because I know where everything is. And this is a handy feature. Basically, will clear. It'll reset the library. So just click there, and you get back the library to its default state. So frames library. Frames are useful. This is a library to be aware of. It defines your paper size, so that when you print it, you don't have to do any weird scaling. Okay. Now notice one thing that's important to notice is that Eagle's default action is group. Okay. In other tools, this could be called select. And if you notice over here in the selection filter, well, right now we don't have enough items to kind of be able to really show off the selection filter, so we're going to hold off on a second. But a couple of things we want to highlight with this option is you can obviously form the selection. If you left click and drag, you can move. Okay. While you're left clicking and dragging and you're moving, if you right click, it'll rotate. And then if you click your scroll wheel, it'll mirror. Okay. So that's something that's useful to know as well. Okay. So let's go ahead and bring in a few other components so we can start exploring some of the functionality. So we're going to go to the RCL library. This is a very important library, one that's good to be aware of. Has pretty much all the passives you could ever want. So in this case, we're going to bring in some 0805 resistors. Okay, R0805. Say OK. Going to bring in a few. Okay. Got that. Okay, good. Let's bring in a few caps.
So by hitting escape, I don't know, sure if you brought that up, but hitting escape just brings you right back to the add command. That way you can select other parts. Sure.
I did not
Okay,
mention this. No, I didn't mention it, so thanks for mentioning it.
Yeah, so every time you hit this, once you place the component, place as many as you need, and then you hit the escape key, and it will just go right back to the add dialog box. That way you can select the other components you want to use.
Mm-hmm. Okay, excellent. I think that's all the components. Oh, no, missing a few more. So I hit escape, came back here. Another library that's useful is the LED library. So I'm going to go over here, LED. Put in one of these just because it has a nice 3D model. By right-clicking as I place, you can rotate. The middle click to mirror applies. So that combination is always kind of valid. And the add command while you're moving, that's all always available. So now we're going to go ahead and show a very important component. That's your supply symbols. Now there's a couple of things that really need to be made clear when working with supply symbols. So we have ground. I want to put it right here. And we're going to power this thing with +5. So a couple of things you really want to be aware of. Number one, never try to rename a supply symbol. Okay? It doesn't work. Supply symbols inherit the net name from the device name. So if we go back to the add command, the device name is the name of the component in the library. This is +5v. For a supply symbol, that's the name of the net it's going to connect to. Okay? So right now we have one ground symbol, but I can use copy. And I can put in a few more where I need them. You're muted, Ed.
It saves you time for not having to go to the add dialog box to go get the part again. Also, make sure that when you're placing components on the schematic, when it comes to placing components as well as defining connections, always work on the default grid. Please never change the grid.
Yeah, if you prefer the metric system, that's okay. Change the units to metric, but leave the sizing.
Yeah, leave the default grid.
Yeah, 0.1 inch or the 2.54 millimeters. Okay, very, very important. Your life will become very difficult if you change the grid.
Now he's using the net command to define the connections. You'll notice that when you pause your net on another net, it automatically will adopt a junction point.
Mm-hmm. In this case, we have a net that's pre-existing. Now we're connecting it to plus 5V. Eagle's asking if it's okay to merge them together. Answer is yes. Very few times have I had need to say no. I can't remember actually any time that I've ever said no. So when in doubt, say yes. Now you notice the commands in Eagle stay active the whole time until you either change to a different command or you escape out. Okay, and this is part of its efficiency. As you can notice, I can just keep drawing my nets. No need to right click anywhere.
You'll notice that when you get close to the connecting point of a pin, it adopts that little bubble.
Mm-hmm.
That lets you know that that's the connecting point of the pin. So that's where you're going to start or end your net.
Yep. Okay, so we're going to go over here. Okay, let's see if I can come around this way. Whoops. Oh, we don't have I tried to do the routing feature that we haven't.
I noticed that you're hitting backspace. Like if you're manually like routing a board.
Yeah, we need to bring that into the schematic. That would rule. Okay, so now we go over here, back to the net command.
Now the net command is the official command to define your connections on the schematic. Avoid trying to use the line command because that could cause a certain amount of confusion. So try to always define your using the net. The line command will work as long as you have the net layer active. It will work, but in essence, use the net command.
So right here, if you notice, I went around, okay, but I didn't need to do that. What we can do is, again, using the copy command, I'll copy this one over here. And this shows kind of the value of supply symbols, okay? If you notice, we have this kind of unsightly net going all over the place. What I can do is I can kind of remove that and then just connect right here to there, and that's it. All supply symbols are automatically connected, okay? That you don't have to draw lines between them. They're automatically connected by virtue of the fact that they're supply symbols. So by doing this, I don't have to draw that unsightly trace going all the way, that unsightly net, sorry, going all the way around here.
Another property of the supply pins is that when you connect a net to supply pin, that net that you've connected will adopt the name property of the supply pin. So for example, here on the plus 5-volt supply pin, when you run a net to it, that net will automatically adopt the plus 5-volt name on it.
Yeah, so that brings us to a very important point in Eagle. All connections in Eagle are defined by net name. So if we look at the name command, you'll notice that every trace has a name. Every single one. Okay, and whenever two nets have the same name, they're automatically connected. So you can have, for example, if you have a very dense design, you can have, a stub here and a stub here. As long as they have the same name, they're connected. They're considered to be connected. And that comes in handy when you're, breaking out 1,000-pin BGAs or very high pin count components. It's easier to do that than to try to do point-to-point connections drawing the different items. So now what we're going to do is we've already drawn our main schematic. We're going to now going to assign values. So if you left click on it, pick over here, I can enter the value. Okay. Another option is if you notice the command line is active, so I can also just type in the value. So I can say 100K, press enter, and now I just click on the part, and if I actually click on another part, you'll see that it automatically gets that value. So that's a really good way of assigning the same value to multiple parts. Whenever you want to switch to another value, just type it in 450K, hit enter.
And this works because he has the value command active. Okay.
Correct. And that's something that's worth getting used to in Eagle, and it'll come. Maybe for some it's a little bit unintuitive at first, but in Eagle you always pick what you want to do first, and then the object to do it on. So you just pick the command, and then you do it on as many objects as you need to. So 0.1. You can tell I like doing it this way. 0.01 micro. There we go. Okay, now the other thing we're missing is a connector to get power into the board. So we have lots of connector libraries. They're all over here. They're all prefixed with con, C-O-N. But for this application, I'm just going to use a really simple pin header. We have a pin head library over here. Pick the two pin header. Say okay. I'll put it over here. I'll rotate it. And now I'll use copy. Bring the ground over. By the way, just in case anybody's wondering, you can also do Control-C, Control-V. So right now I've clicked on that +5. I do Control-C. I do Control-V, and there it is. Okay, so you have the normal shortcuts as well. Okay, awesome. So now let's talk a little bit about how we can use these new features, the selection filter and the inspector, since this is new. I think we're good on time, right? I can take a little time to explain. All right, cool. So if you notice, right now everything is selectable, okay? But let's say we were only interested in selecting the parts, okay? So I click here, now only parts are selectable. So I can draw a really big group, okay? I'll just make a really big group over here. And what you're going to notice is that all the components are selected, but none of the nets are. Okay, you also notice that none of the text is actually part of this group either. Okay, and that's what the selection filter allows you to do. It makes it really easy to be able to form precise groups. Now let's say, let's try it another way. Let's say this one wouldn't be too helpful for this application, but let's say I only want to get the junction dots. And there we go, the junction select. Now, how is this helpful? Well, in first case, it makes it easy to form complex groups, but in another sense, you can actually do things that are a little bit more sophisticated. So let's say we're back to parts, right? And I go ahead and I click here, and I pick these, and I go to the inspector. And notice that the inspector shows you what objects have been selected or which ones are in the group. Okay, so we have devices. There's certain things that they have in common. You can make attributes for all of them also. Okay, so for example, I could have them all have part numbers if I wanted to. And if you look here at the bottom, there's actions you can do. So you can, for example, mirror them all, rotate them in place, replace them. So if you form a group with 1,000,000 resistors in it, you can very easily swap out all the footprints. So it's an extremely powerful tool, and the more you use it, the more ways you find to use it. Okay, and here it lists all the properties, tells you footprints, tells you all of that stuff. So that's one of the key new features that comes into play, and it's always in play. So if you just want the group to select everything, just make sure everything is selected. If you find that you're in a state that you just want to have everything like before, just hit reset. It'll restore it to its default selection filter, which is basically select everything. You're muted. Ed.
It's possible to change to just select a single component and use the inspector to change the properties. Like you were setting up the values
Mm-hmm.
in the way that you did it with the value command. It's possible to have it done by selecting that part by itself, as he just did, and then right there you have a value which you could have done right there as well.
Yep.
Um, Actually, that's the way I prefer to do it. To be honest with you, I prefer using the inspector and just go part by part. And that's how I use the inspector to change properties on my components. I use it heavily in the library as well.
Mm-hmm. Extremely powerful. As you can see, you have all the quick actions that you can do on the object as well. Okay, so the other thing we wanted to show, and I think that's the last thing we're going to show, is the UOP. So UOPs stands for User Language Programming. And basically these are little programs that users can write to automate tasks in Eagle. Now UOPs can access all of the drawing objects. So you can literally modify your design, writing your own programs and implement features even. So there's a lot that we get done through these. So as a quick example, I'm going to click on UOP. And you'll get this dialog. The script dialog is similar. You notice that it actually defaults to the examples location, but if you have personal UOPs, you'll notice that it's willing to go to the Documents Eagle UOPs folder. So if you make any custom UOPs, that's where we encourage you to put them.
Or you download UOPs from somebody else.
That's true. If you download, that's where they should go. So we'll pick Bill of Materials, say OK. And you'll see here we have our Eagle Bill of Materials. I can organize it by values, so that way we get quantities of components. And this can be saved as a text format, as a character separated value list. A lot of people think CSV stands for comma. It does not. It stands for character. Okay, and then you can just save it and make whatever modifications you need to do to it. Okay.
Also, if you add attributes to the components, they will show up on that list as well, if you were to add attributes to the parts. First of all, we wanted to show you how to start your project, how to create the schematic, put your frame down, how to search for the components that you're going to actually be using, place them, and define the connections as well, and the selection filter as well as the inspector.